Welcome. I am from Roy Physics. I am going to discuss with you today lecture 2. Topic of discussion will be Gauss's law. That is the basic law in electrostatics. First, what is the mathematical form of Gauss's law? First concept is what is flux. What is flux? Electrical flux. How can you determine electrical flux? Suppose this is electric field E. You are consider a surface ds. Now area vector of the angle making theta. Then component of electric field along the direction along the normal, that is along the direction of area vector, that is E cos theta. Now flux equal to total electric field or electric line, total electric lines of force passing through the area considered. So we have E ds cos theta is the flux, where theta is the angle between the electric field vector and area vector. You always imagine the area vector is always perpendicular to the plane surface. Now we have flux equal to E dot ds. So in your exam, if flux to determine this equation number 1, it is clear from that if you want to calculate flux, you take electric field as well as area vector, that will be given in vector form. Now if you take the dot product, we are getting flux. That is very important before launching Gauss's law. Now question number 2 is what is statement of Gauss's law? Statement of Gauss's law, that is also important. Question number 2, statement of Gauss's law and mathematical form. And mathematical form. Now this Gauss's law tells, if you imagine a Gaussian, suppose total electric flux through any closed surface E dot ds equal to charge inside the surface by epsilon naught. That is equation number 2. Again I am telling, suppose you imagine this is charge, you imagine a spherical Gaussian surface, then total flux E dot ds equal to charge enclosed by the surface and by epsilon naught. Always remember, charge you consider only inside, not outside. This is the statement of Gauss's law. If you know that charge inside a surface, you are getting electric field from that equations. That is the basic law of Maxwell's equation, one of the law, that is Gauss's law. Next, I should apply this Gauss's law to determine electric field for different symmetrical bodies one by one. Now question is application of Gauss's law. Application of Gauss's law. Question number 3. Suppose there is a charge rod, electric field is perpendicular to that, length of the rod is L is the length of the rod, charge lambda equal to total charge by length, that is linear charge density, that is called linear charge density. Now you take the rod at the middle of the Gaussian surface. So you want to calculate electric field at the point P. Calculate field at the point P. Clear? So what will you do first? You draw a Gaussian surface taking the point P. That means you consider symmetrical cylindrical Gaussian surface, because this rod will be height of the cylinder. So now we consider 3 surfaces, that is the curved surface and top surface and bottom surface. Top surface top surface S2, that is the bottom surface S1, and curved surface. Now it is clear that top surface, that is the direction of area, and that is the electric field. Angle is 90 degree. So total flux E dot ds at top and bottom surface E dot ds, that is S1, that is S2, E dot ds equal to 0. Why? Because E is perpendicular to area vector at top and bottom. At top and bottom surface. That means you have to consider only flux through the curved surface. So we have flux through curved surface. We are getting E dot ds equal to total charge lambda L by epsilon naught. What is E? I don't know. Area is 2 pi RL lambda L epsilon naught. It is from here you are getting electric field equal to L cancel, lambda by twice pi epsilon naught by into R by R. Graph will be like this. That is the R and that is the E. It will be like this. So it is clear that electric field for cylindrical rod. It is electrical field for charged cylindrical rod. It is finite or infinite, whatever it may be. That is one of the applications. So one of the applications is charge rod is there, charge plus, then you consider a Gaussian surface that is cylindrical. After that you consider top surface, you consider bottom surface. Both cases flux is 0 because E and N and E 90 degree. So only consider flux through the curved surface. We are getting E equal to lambda 2 pi epsilon naught R. Now I am another equation I am trying to derive from you, that is, okay, this is very disturbing. Now I am considering another one, that is charged spherical cell. You write down electric field application 2, electric field application 2, that is electric field for charged spherical body. First you consider charged spherical body, you know, hollow. It is charged spherical body bracket hollow. Now if you consider the point P at a distance R, you draw a Gaussian surface, spherical, you draw a Gaussian surface. Clear? Now you consider E dot ds. If you apply, then it is coming total charge enclosed within the Gaussian surface Q by epsilon naught. Now question is that what is E? I don't know. So E area equal to 4 pi r square Q epsilon naught So E at P equal to Q by 4 pi epsilon naught into R squared. Clear? Now if the P is outside, as if the whole charge is concentrated at the center. If it is center, according to electric field at the point will be Q by 4 pi epsilon naught by R square. For discrete charge, this formula you have already known, that for discrete charge Q by 4 pi epsilon R square, that is the as if the whole charge, not charge body, whole charge has been concentrated at the center point of the spherical shell. Now case 2, if the consider the point case 2, if R equal to R, then it will be equal to Q by 4 pi epsilon naught R square. Number 2 equations. Now consider the point inside the P1. Case 3 at P1, you know E dot ds total charge 0, because if you draw a Gaussian surface inside the spherical shell, what is the charge within the spherical Gaussian? If the Gaussian surface is inside the sphere, then total charge residing outside the surface, not inside. So inside total charge will be 0. So naturally I should write 0 by epsilon naught E equal to 0. That means this is the area inside the spherical shape. It is a hollow, that inside electric field is 0, means no lines of force passing through this, and E equal to 0. But one thing to remember, E0 does not mean V equal to 0. V will be Q by 4 pi epsilon naught R. If you to draw the graph, what will be the nature of the graph? Now in this case, if you represent the graph, it will be like this, graphical representation. I am telling you, that is the first R maximum, then it will be like this, and it will be 0, that is equal to 0, then E maximum, then E proportional to 1 by R square. This is the graph E versus R. So question will be like this, if you consider a hollow spherical shell, there are 3 different points. One is outside the shell. If you draw a Gaussian surface, in that case it is formula is coming E equal to Q by 4 pi epsilon R square, because as if whole charge of the hollow sphere is concentrated at the O point. If R equal to R, then you are getting E equal to Q by 4 pi epsilon R square. If you consider a point inside the shell, if you draw a Gaussian surface inside the shell, what we are getting? E equal to 0 are getting. So this is the second application for hollow sphere. Now if I consider a non-conducting solid sphere, that means charge is uniformly distributed throughout the sphere. In that case, let us consider the application number 3. Then application number 3, question is calculate E for solid charged sphere. Clear? Suppose this is sphere. If it is solid, charge density rho equal to total charge Q by 4 by 3 pi R Q. That is the charge density. Clear? If you consider a point P, draw a Gaussian surface. Then we have apply E dot ds. Total charge within the Gaussian surface is the net charge of the sphere, that is Q by epsilon naught. Now you consider E, area 4 pi R square, formula same, Q by epsilon naught. You are getting E equal to Q by 4 pi epsilon naught R square. This is equation number 1. In that case also it is considered that whole charge is considered the center. As a result, we are getting electric field at the point P, that is equal to Q by 4 pi epsilon r square. No problem. Case 2, now if r equal to capital R, then you are getting ER equal to surface, you are getting ER, you are getting Q by 4 pi epsilon naught r square. No problem. But problem is that if we consider a point P1, that is from X, now consider, that is very important, you consider a point P1 inside the sphere, then you consider the Gaussian surface for the small sphere. In that case, what will you do? You consider total charge contained by the sphere or at a distance x. From the center at a distance x, that is a point P1 which is inside the sphere. Now for that point P1, we have to consider the total charge within the small sphere. We have integration E dot ds, total charge suppose Q1 by epsilon naught. Now you write down E 4 pi x square q prime equal to 4 by 3 pi x cube by epsilon naught into density equal to 4 by 3 pi r cube, cancel, you are getting E inside equal to, what will you get, x square, you are getting qx by 4 pi epsilon naught into r cube. Clear? So in that case, E inside proportional to x. What is the x? X is distance from the center. Graph, what is the nature of the graph? Graph will be like this. Remember, so E, that is the distance x, that is E. Now first it will be E proportional to x straight line, then it will be maximum x equal to r, then will be like this. Graph will be, that is E proportional to 1 by r square. So this is the gap. This is the first increasing, then it will be maximum at x equal to r, then it will decreases at the rate E proportional to 1 by r square. So this is the case for the solid non-conducting sphere. After that, I am considering application number 4. Application number 4, very important. Suppose a charged plane sheet, E for charged plane sheet. This is a charged plane sheet. You consider a point P top and point P1 and P2. You take small area, then you consider a Gaussian surface. That is a plus charge. Suppose electric field will be top like this. In that case, density of the charge, density equal to sigma, density of charge, sigma like this. So we consider only 3 surfaces, surface 1, surface 2, surface 3. Here E dot ds for curved surface equal to 0. Why? Because in that case E perpendicular ds. Clear? Now top and bottom we have same, S1 E dot ds equal to S2 E dot ds. So we have 2 S1 E dot ds equal to total charge enclosed by the cylinder sigma ds by epsilon naught. So we are getting E equal to sigma by twice epsilon naught. It is clear that electric field does not depend on the distance from the surface. Whatever be the distance, E does not depend on R. It is constant value. Clear? E dot is 0. Why 0? What 0? That is at the curved surface, because E is along direction, N is along the direction, angle is 90 degree, E perpendicular ds vector, E vector perpendicular ds vector for the curved surface. Now for E did that flex through this surface and flex through this surface same, so we have E dot ds s1, E dot ds s2, both are equal, so we have getting this result. But this is very important for all of us. Last one. Now any student can ask me that what is the electric field for conducting slab. In that case, very interesting. Conducting slab, you know, charge is residing at the surface. So if you consider a conducting slab, you are conducting slab, suppose you are conducting slab, you draw. If you draw the Gaussian surface, clear? This surface sigma ds charge, sigma ds, in that case E dot ds equal to 0 by epsilon naught equal to E0. You know, inside the conductor no charge is there, so total charge is 0 by epsilon naught. You write down E dot ds equal to 0 by epsilon naught, and just logic you give Q inside equal to 0 for conductor, that is inside for conductor. So naturally we are don't consider flex through S2 surface, don't consider any flex, consider flex inside the surface, inside the along the inside the, don't consider the flex through surface inside conducting slab, because Q equal to 0. So what are we getting? Only considering this surface A, so flex through A, E dot ds equal to total charge sigma ds by epsilon naught. So E P, if we consider P point, you are getting sigma by epsilon naught. Very important. Another one, if there is a consider two plates, one is plus sigma and other is minus sigma, or both you consider sigma 1 and sigma 2. Now point P Q, that is the positive direction, that is the negative direction, and that is another point R. You will see that is negative means here it will be minus 1 by twice epsilon naught sigma 1 plus sigma 2 at EP, Q equal to plus 2 sigma 1 plus sigma 2, and ER it will be 1 by twice epsilon naught sigma 1 minus sigma 2. But if sigma 1 equal to plus sigma and sigma 2 equal to minus sigma, so it will be EP will be 0 to EQ, but ER will be sigma by epsilon naught. That is very important. Again I am telling, suppose this is a plate A, this is a plate B, it is sigma 1, it is sigma 2. Now consider the field at the point P, at the point Q, at the point R. That direction is negative field direction, that is the positive. So you are considering E1 in the direction, it will be E2 like this. So at the point EP, again I am telling you, minus, give minus sign, 1 by twice epsilon naught sum of the charge. Why this? Because for that plate it will be minus sigma 1, for that one sigma 2,
due to superposition E1 plus E2, so we are getting this one. Similarly, EQ equal to 1 by twice epsilon naught sigma 1 minus sigma 2, and ER equal to plus 1 by twice epsilon naught sigma 1 plus sigma 2. After that, if you tell sigma 1 equal to plus sigma, sigma 2 equal to minus sigma, then it will be EQ equal to sigma by epsilon naught, other one is 0, and EP and ER equal to 0. Thank you all. Next video I shall do some numericals based on electric field and that one electric intensity and field. That means lecture number, it is the class 12 CBSE initiative based, that is syllabus based, and Gauss's law and applications. Clear? So the topic of discussion today you know date 11/2/24. Dear children, if you get benefit from this channel, because I shall give trace on fundamental on physics theoretical part, at the same time few numericals I shall try to interact with you so that concept can be clear. So it is, if possible, subscribe my channel and wait for my next video. Thank you all.